Good morning, ladies and gentlemen. Thank you for the opportunity to speak to you guys today. I was going to talk about the regulatory protection in South Africa and elsewhere. I've kept my presentation to focus on that. However, I think having listened to the first presentation, I should just stand still a little bit at exactly what it is that we are trying to protect. And it's from a scientific perspective, with my foot halfway into the law, I always work in this field on the interface between law and science. And I'm trying to make sure that scientists understand the legal language, but that lawyers need to understand the technical language as well, and that we clearly understand what it is that we need to protect. Now, this is part of a paper I did for the Environmental Law Association and for the Groundwater Division of the Geological Association of South Africa. And I did it in collaboration with a lawyer and a scientist, Dr. Germarie Viljoen from the Northwest University and Dr. Fanny de Lange from the University of the Free State. And we decided to just make this presentation and discussion to ensure that we understand exactly what it is that we want to protect when we talk about the protection of aquifers. So I'm quickly just going to firstly talk about why are aquifers important from a socio-economic perspective, and then stand still and give you maybe a little bit of understanding of the two main risks that we need to protect against. And that is the risk of over-obstruction and the risk of contamination. And then looking at our current regulatory systems that we have in place to protect aquifers, and then why is it not so effective in South Africa, and what are other systems used in other countries to protect their aquifers. So in short, to begin, this planet that we live on looks like it should be called water, but in fact, the amount of water that we have is just a thin layer on the surface, and it is 1.4 billion cubic kilometers in total, of which 96.5 is saline water in oceans, and of the remaining 3.5%, 30% is underground as groundwater, and only 0.256% is found in lakes and rivers. But groundwater being an invisible resource, you regulate what you can see, and because groundwater is not so easily seen, it is the invisible resource. Most of our previous legislation and still current legislation focuses very much on the 0.256% of surface water that we can see, and not so much in the groundwater. When we look about what is an aquifer, we get the hydrological cycle that you all learned in primary school, where there's evaporation and precipitation, and then there's a runoff back into rivers. But there's also a large amount of water that seeps and infiltrates into the soil. And at the point where the soil becomes saturated, that is where the aquifer starts. So there's quite a large area above an aquifer that is not part of the aquifer, and legally not part of what the Department of Water Affairs can regulate with the National Water Act. It is important to understand that whatever happens on the land will in turn eventually influence and impact on the groundwater. And if we abstract at the rate greater than what the natural precipitation can recharge, we will deplete an aquifer. So this just gives you an idea of how long does water stay in the water cycle, and where you have a surface water impact and a sewage work spill into a river, within 11 days, that is no longer visible, it's in the ocean and you can't see it. The recycling rate is 11 days. Whereas for groundwater, the rate of recycle, in other words, the time it takes for one drop of water to move through the entire cycle and fall down as rain again, is on average 280 years. And so you have certain areas known as an aquifer recharge area where high rainfall replenishes the aquifers, and then it can take years, decades, or even centuries and millennia before that water comes back out and becomes part of the evaporation, precipitation, and rainfall cycle again. Now, for this reason, because the water is so long in contact with rock underground, it takes on the characteristics of the rock in which it is held. So if you have rock that have high concentrations or levels of, for example, cyanide or arsenic, your water quality in the aquifer will also have the same quality as the rock. And for that reason, it is not so easy to say the groundwater has been polluted. Groundwater always requires analysis and may need treatment to be suitable for human consumption. If an aquifer is naturally influenced with things like arsenic or cadmium or sodium, which happens all over the country. I mean, in Barberton, for example, the natural cyanide levels is so high that if you will drink it, you will definitely die. In the Kalahari and in the Karoo, you get areas where the magnesium sulfates are incredibly high naturally, and that water needs treatment before people can use it. So in terms of the protection of the aquifer, we cannot say all aquifers must meet human drinking water requirements naturally, because it simply is not scientifically correct to want that. Aquifers also contributes to the base flow of rivers. If you go back to this picture, how it takes from the aquifer and it flows into rivers. And in especially the Cape Flats area, more than 100 millimeters per annum of the flow in rivers are direct contributions from water held in the aquifers. We also have a large number of so-called aquifer-dependent ecosystems, and that would be wetlands and certain phreatic plant species that are dependent on their survival for aquifers. And obviously, these are also areas where you will have shallow water tables. And if the water table meets the surface of land, that is when you get something called a wetland. Now, from a socio-economic perspective, groundwater is the largest reservoir of fresh water that is readily available. And some 2 billion of the 7 billion people on Earth depend on it for their water supply. It provides low-cost, drought-reliable, and high-quality water supplies in many cases for both rural and urban populations, which is vital for achieving sustainable development goals. And because it's underground, higher temperatures, higher evaporation does not threaten it, and therefore it provides resilience from the effects of global climate change. However, the replenishment is finite and limited to shallower aquifers. We can overexploit it, and we can seriously degrade the quality by certain land use activities that cause pollution, which now will cost extra money to take the pollutants out so that it can be useful for humans. This is a map by the Department of Water Affairs, which shows the utilizable groundwater exploitation potential. In other words, how much cubic meters per square kilometer per annum can we take out of the aquifers and use for our supply? And as you can see in the Cape Town's flat area, between 10,000 and 25,000 cubic meters per square kilometer, which is quite a lot of water if you are in a water deficit area. We use it after we've abstracted for a whole range of things: to drink, provide for municipalities, crop irrigation, livestock watering, and industrial use. And this graph shows you the groundwater use per water management area, which shows that in the Cape Town catchments, most use are for municipal purposes or for irrigation purposes and for industrial purposes. Groundwater is the sole or primary source of water for 926 cities, towns, and villages throughout South Africa, including in the Cape Flats area. And in this graph shows areas which is totally or 100%, almost 100% dependent on groundwater for irrigation purposes. The area circled up there in red, the Dalmas Aquifer. I will show you a little bit later a small case study about how the lack of protection of that aquifer is threatening food security in Gauteng. Groundwater is potable mostly without extensive or expensive treatment in most cases. But remember, the rock influences the quality, therefore it must always be checked and tested. And it employs low-cost technology compared to surface water. How do we get to the groundwater, to the water in aquifer? With a borehole. But the borehole construction itself can impact and can affect the aquifer and the water that we take out of the aquifer. So when we talk about groundwater protection, we also need to address aspects such as borehole construction. Especially in the Cape area, we can get what we know as borehole fouling, where high iron deposits can contaminate the groundwater, and that's not as a result of pollution, but as a result of poor borehole construction. When we abstract water from an aquifer, we form what is known as a cone of depression. That is, if you put the straw into a milkshake and you suck, it will go down around the straw. And it's exactly the same principle. So over abstraction can cause dry wells on neighboring properties if one property owner abstracts too much. A number of other anthropogenic activities can also potentially place aquifers at risk. And if you think that that hydrological cycle I showed you earlier is still the way it works, it's not. Humans and our interventions have changed the hydrological cycle in every step of the way. And so we still have evaporation and precipitation, but we take water out from streams, from boreholes. We create recharge areas and recharge zones, and we create cones of depression every time we access groundwater. Over abstraction of groundwater can seriously damage large areas of development, including the socioeconomic activities in those areas. The photo on the right at the bottom is of the Aral Sea, where a ship is stranded because of over abstraction of groundwater. Excuse me. In the upper reaches, the entire feeding flows into the Aral Sea has disappeared. And the aquifers was damaged to such an extent that there is no longer an Aral Sea, and you can go down a rabbit hole and Google that tonight. A large number of over abstraction can also cause the land surface to drop. That is known as subsidence. And in certain areas where you especially have dolomitic karst aquifers, you can find sinkhole formation where the soil literally falls away. And in the far west rand, sinkhole formation has sterilized the entire area that is no longer suitable for housing development. And the pipe you see on this photo is the Wonderfontein Spruit, which had to be piped across about 50 kilometers so that it doesn't add to more sinkhole formation and that the water is not lost. If we make rules to regulate groundwater, we are often try to make those rules very simple and minimalistic and rule-based. For example, no septic tank within 50 meters from a borehole. But if you look at the top example, the septic tank is 100 meters from the borehole, and yet because of the geology, the septic tank directly impacts on the drinking water borehole. In the second example at the bottom, this geology and the septic tank there is much closer. Drops its load into the Vado zone where it's useful and not into the aquifer itself, and there's no impact on the borehole delivering clean drinking water. So one has to understand the science quite well in order to understand how to regulate it. And for groundwater, it will always be site-specific, because I can literally walk 10 meters and be on top of a completely different aquifer. A large number of land-based activities can influence and can impact on groundwater, including as a mine waste, drainage, fertilizers and pesticides from agriculture, septic tanks, animal husbandry, large-scale use of fertilizers, garbage sites, waste disposal areas, gas tanks and leaking underground storage tanks is a great concern, especially in an urbanized area such as the Cape Flats, because there's very little control over the leaking underground storage tanks at filling stations, and so on, salt tanks, fuel tanks, etc., as well as factories and industrial premises. There's a number of factors, as I said earlier, that influences groundwater quality, not just the activity of humans. And that means that we simply cannot have a one-size-fits-all approach to aquifer protection. This map shows the potability of South African groundwater based on salts. And from this, you can see that while in the Cape Flats area, your salts is in this area a range of 70 to 150 millisiemens per meter. In the Northern Cape, it can be above 500 millisiemens per meter naturally. And the same goes for nitrates. Now, nitrates is of particular concern or importance because nitrates leads to a disease known as methemoglobin anemia or blue baby syndrome. And any sewage pollution, any over-fertilization can increase the loads of nitrates. However, in certain areas of the country, nitrates do occur naturally as a result of the presence of certain minerals in the geology. And therefore, one can again not just assume that water quality is suitable for human consumption. This map shows you the fecal pollution in our aquifers, and it shows that especially the Cape Flats aquifer has been quite severely contaminated with fecal pollution, which is a direct result of poor sanitation and poor sanitation practice. To summarize, the protection of groundwater should be a high priority in South Africa, but we need to understand very clearly what it is that we want to protect. And there's two aspects in relation to that. And that is prevention of over-abstraction, ensuring that there's sufficient replenish the aquifer, and preventing unnecessarily anthropocentric impacts on the aquifer. In terms of our regulatory systems that we have, because aquifers, water are public goods, we need to have it protected for the benefit of the public. However, the risk of pollution arises from legitimate activities within society. We cannot say, don't have sewage works because it causes aquifer pollution, or don't have pump stations because it causes aquifer pollution, or don't have sand mines because it causes aquifer pollution. All those activities are legitimate activities. What we need to do is ensure that the management measures are in place, that those impacts can still be managed. And from an aquifer perspective, groundwater perspective, we simply cannot have rule-based approaches. We must have site-specific, risk-based approaches. And such an approach was followed under the old 1956 Water Act, where although water was regarded as private water, which didn't imply a right to own, but a right to privately use. And the same in the new Act, you have the right to use. Although that was the case, the government declared 16 subterranean aquifer protection zones between 1956 and 1994. The extent of those were quite limited, and it only prevented effects from over-abstraction and did not consider land use activities. And if you look there at the Cape Flats area, there were at least 6 of those zones in that area which are still in force, but only as exempted area under some general authorizations. And the enforcement of the protection of these protection zones has not continued under the new Water Act. What we have under the new Water Act is the concept of resource-directed measures, which says we must classify water resources, and for each significant water resource, establish resource quality objectives, which could relate to both quantity and quality. This, however, in the implementation and development of the methods of the Department of Water Affairs, really focused mostly on surface water and not so much of groundwater. And the promulgation of certain resource quality objectives did not even mention the subterranean government control areas that had been established under the preceding legislation in those catchments. So this resource-directed measures was ultimately aimed to protect aquatic ecosystems. But very much of the groundwater resource that we have and that we can use in the future are very deep and do not support aquatic ecosystems. So the overemphasis on aquatic ecosystems actually led to a lessened protection or a lower protection of aquifers. And this is the case study in Delmas, where the people have been using dolomitic good quality water for many years. But because of lack of sanitation and poor management by the municipality, there was a 2005 outbreak of cholera. And as a result, 3,000 people were hospitalized and 9 people died. In 2020, an application for a mining license to mine coal has been approved, and this water from the aquifer is used for large-scale irrigation of especially vegetable crops. It's the vegetable garden of Gauteng. More than 75 such privately boreholes were identified, and it predicted in the mining application that concentrations will reach up to 1,200 milligrams per liter only after 25 years. Blasting of the shale will also shake loose the suspended solids in the aquifer itself, the so-called wadi, and this was not even identified as an impact during the EIA process. Although dolomitic aquifers are especially prone to sinkhole formation and subsidence, these aspects were not addressed as possible risk during the mining activities. And the result was, and this is just some maps, this show you the blue area, that's the dolomitic aquifer that is so vulnerable there at Delmas. And all those red spots are the currently used large-scale abstraction boreholes used for the vegetable irrigation. And in spite of that, this is what the sulfate plume prediction shows, how many of those boreholes will be detrimentally impacted and affected. And approaching the Department of Water Affairs was not effective. They simply said, but we don't have the power to do anything about it. So that raises the question, why is our current regulatory protection of aquifers not effective? And there are a number of gaps that we've identified. Firstly, the overemphasis of biodiversity and the ecological reserve at the expense of basic human needs, which places the focus too much on surface water, and it does not protect aquifers with socioeconomic importance. No consideration of existing subterranean government protection, groundwater protection areas, no mechanism to classify aquifers, and we cannot amend resource classifications once they've been promulgated. We also do not see any compulsory licensing in areas where there's high aquifers of high socioeconomic importance, and there's no special consideration for even currently declared subterranean government control areas. Under the EIA and ENPR requirements, there are no compulsory peer review mechanisms, and the evaluations are done by inexperienced officials who make recommendations to ministers whose objective is to promote mining, and ineffective appeal processes which do not regard serious socioeconomic impacts on especially agriculture and consequently food security as significant. And this means we do not currently properly protect our sensitive aquifers that are appropriately and that are important from a socioeconomic perspective. So how do we address these gaps? In certain other countries, the concept of an aquifer protection zone has been established, where regulatory control is placed on certain activities taking place on land that overlies vulnerable aquifers or the recharge zones of such aquifers. In essence, a subterranean government control area that we have in South Africa is an early type of an aquifer protection zone. And in these other countries, it's normally achieved through legislation used for land use planning. They all normally have 3 different types of zones per each aquifer, and with each protection zone, various levels of land use constraints are imposed and are more stringently the closer you come to the borehole operational zone. So you will have a wellhead protection zone immediately adjacent to the site of the well to prevent rapid ingress of contaminants, an inner protection zone, which is based on the time expected to be needed for a reduction in pathogen presence, especially things like E. coli, which is a problem on the Cape Flats, and then an outer protection zone, which is based on the time expected to dilute and effectively attenuate slower moving substances, as well as to identify and implement remedial intervention. And further, much larger zone sometimes covers the recharge area of a particular aquifer, especially where you abstract water for potable purposes in order to avoid the impacts of depletion of the aquifer or over abstraction. The extent of each zone must be determined based on the site specifics using recognized scientific measures. And it's not just based on a thumbs up. So it's rule-based, not risk-based. And we cannot simply say, oh, we must have these rules for the entire Cape Flats aquifer. We must be specific about what kind of rules do we want in which area. And these are typical examples of the constraints. For example, in the inner protection zone, you will not have cattle kraals or feedlots or sewage sludge or pit latrines or mining. And in the outer areas, you will not have things like waste disposal sites, chemical plants, oil refineries, and hazardous waste storage underground. We can implement these aspects within the South African legal framework, and I'm almost at my conclusion, because groundwater relates to two aspects, water and land, which are currently governed by separate departments. So to govern it as water, we would need amendment to the National Water Act to allow for the revision of the resource classification system, which we've already promulgated in 2011 and currently does not make provision for aquifer classification or for the identification and protection of significant aquifers. Under the land use planning legislation, the Spatial Planning and Land Use Management Act, SPLUMA, which is supported by provincial legislation, we can achieve the implementation of zoning areas through integrated development plans and spatial development frameworks. And the implementation of land use planning schemes is essentially saying this zone, like an African aquifer protection zone, should not have certain activities. It uses zoning as a primary land management tool. And the purpose of the zoning is to say, in this area, these land uses are acceptable. And in that way, we can say, let's avoid the establishment of filling stations or feedlots within our high priority recharge zones. Zoning on a municipal level might not, however, protect sensitive aquifers because some of these things stretches across municipal boundaries. Therefore, it's also necessary to provide on a mechanism over areas wider than a particular municipal jurisdiction. In conclusion, the link between land use planning and groundwater protection has not properly been translated into control mechanisms in our South African legal framework. Declaring especially certain recharge areas as groundwater protection zone and limiting the type of anthropogenic activities that can place on these areas will facilitate the protection of certain groundwater resources. But that is difficult to achieve where the institutions involved and governments of water and sanitation, agriculture, environment, and municipal government do not always talk to each other. They operate in separate silos. Land use planning zones and regulations at aquifer level can actually be effective tools, and aquifer protection zones can be incorporated into the current land use planning schemes. Therefore, it is recommended that policy documents and guidelines be drafted by geohydrologists and other relevant environmental scientists, as well as environmental law specialists, to facilitate the establishment of these zones as a matter of priority. Understanding always that we need to know what it is that we want to protect and why we want to protect it. Good environmental governance needs good environmental science, and that is why we need to integrate these two things when we talk about aquifer protection zones. Thank you very much.